Okay, we're on page 83 in your journal. So we're going to be talking about addition and subtraction equations. All right, so we're going to define a few things and then I'll show you some examples so those definitions will make sense. So when you see equations, all right, you see this side of the equal sign and then you see this side of the equal sign. All right, so this side of the equal sign has to be equal to this side of the equal sign because it says it is. They use the equal sign. So I want you to think of it as like a science balance. If you're going to add 5 to this side, you better add 5 to this side. If you're going to subtract 10 from this side, you better subtract 10 from this side because they do have to stay equal. So with addition, okay, and this is an addition equations, this is just with addition. So if the same number is added to both sides of the equation, the two sides remain equal. So again, if you're going to add, you have to add the same number to both sides of the equation so that they will remain equal. Same thing with subtraction. If the same number is subtracted from both sides of the equation, the two sides remain equal. And again, remember, if I'm ever going too fast, you can pause it. So let's look at this first example. This is a subtraction equation, all right? Some number here that we're trying to find, y minus 16 equals 30. So remember with subtraction, this is your total, this is a part, and this is the part that you have left over. So I know that you probably know how to find the answer to this. I'm not really teaching that today. I know you could probably find out, what number goes here on your own. I'm teaching you the process of solving equations. So you're going to use this process in 7th grade, 8th grade, algebra, all the way to college, in any kind of solving equations. So we're going to put a line and we're going to separate this side of the equal sign from this side. Okay, think of it like that science scale. This side versus this side. They have to stay equal. They have to stay at that same level. So in order to find this number, this is what you're solving for. You're solving for y. So we want y all by itself on this side of the equal sign. So if we want y all by itself, we need to get rid of this subtracting 16. All right, in order to get rid of subtracting 16, we need to do the opposite of subtracting 16, which is adding 16. All right, and again, what I do to one side, what it says up here, what I do to one side, I immediately write down and do to the other side. So this right here, I want y all by itself. So if I subtract 16 and then add 16, my sum is 0. So that cancels out. Make sure you mark that out. And then this side tells you what to do. 30 plus 16 is 46. And then box your answer. So to check yourself, if you're saying y is equal to 46, in place of y, put 46 and look at the original equation. 46 minus 16 equals 30. Yes, that's true, so you know that you found the right answer. So on an addition equation, you're going to do the exact same steps. Draw your line, separate one side of the equal sign from the other. We're going to solve for a, that's what we're trying to find. Okay, notice the variable stays on the same side of the equal sign as it is originally. If we want to get rid of this plus 21, this adding 21, because we want a all by itself. So if I want to get rid of adding 21, I'm going to do the opposite or the inverse operation to solve. So the opposite of adding 21 is subtracting 21. What I do to one side, I do to the other. If I add 21 and subtract 21, that gets 0, that cancels out. And now I'm going to go ahead and subtract, that's 22. If I put 22 in place of a, 22 plus 21 equals 43. So a equals 22 is my answer. All right, on this one, we learned, I think you've learned in the past, or maybe you haven't, that a straight angle, okay, all the way from here, all the way to here, is 180 degrees, all right? So from here all the way to here is 180 degrees. So this angle x plus 30 is going to equal 180 degrees. So now we just solve it exactly like we've been solving it. We draw our line. I'm going to do it in another color. We draw our line. We solve for x. Well, how do we get rid of adding 30? What's the opposite or the inverse of adding 30? Subtracting 30. So we get rid of that. 180 minus 180 minus 30 is 150. So 150 degrees would be this obtuse angle right here. Right on the front. This next one, okay, so when you have a word problem, okay, you're going to write down what your instincts tell you to do. So Jose's grandma gave him some money. He spent $85.14 on a skateboard, and he had $14.86 left over. So that's how much he had in his pocket still. How much money did his grandma give Jose? So we're going to say how much money his grandma gave him is X, because it does not give us a variable, so we're just going to make one up. So I would have to have more money than $85 in order to spend $85 and then have $14 left. So my instincts are telling me that I need to go ahead and add how much I had left plus how much I spent, and that would give me how much my grandma gave me. So my instincts is to add. So let's think about what kind of equation would let me add to solve it. All right, so it would be the opposite of addition is subtraction. So we're going to start from the back and read from right to left. X minus 85.14 equals 14.86. So X minus $85.14 equals 14.86. So now if we want to solve it, we're going to do the same thing we've been doing, the same process. So we're going to draw our line on the equal sign. We're going to solve for X. I want to get rid of subtract $85.14, so I'm going to add $85.14. What I do to one side, I do to the other to keep it balanced and equal. If I subtract this and then add the same amount, I'm going to get 0, which cancels that. And now I'm just going to do what this tells me to do. So Jose's grandma gave him $100 to start with. And we're going to go ahead and get rid of this one.